Today we're going to be talking about the metric system and powers of 10. Now the units of measurement that most of you are probably familiar with is called the English system. That uses things like inches, feet, miles, ounces, gallons, things like that. Now the reason why we don't use that system in physics class, I'll give you an example right here. If we consider this problem here, convert 5.2 miles into feet. The first thing you have to do in that problem is to find out, okay, I know that there are 5,280 feet in 1 mile. And then you multiply that by 5.2 miles. You probably have to get out your calculator or maybe do some longhand multiplication, and eventually you figure out the answer is 27,456 feet. That's very complicated, and it has a lot of different conversion factors depending on where you're going. If you wanted to go inches into miles, you would have to know 12 inches per foot and then 5,280 feet in a mile. And there's nothing very standard about it. So we use what's called the metric system, and the metric system uses powers of 10 to move between our units. Now here's what that looks like. We use what's called the ladder method. In the center, we have something called a base unit, and you're just moving a decimal point. You're moving it to the right when you're going down the ladder. You're moving it to the left when you go up the ladder. And these are our prefixes for the metric system. Our base unit, meaning we have, like, say 1, is going to be 10 to the 0. I apologize for that bad writing there. That should say 10 to the 0 power. Okay, that's our base unit, so 1 of something. If we go up our ladder, then we have 10 to the 1, that's deca, that's 10 of something. 10 to the 2 is hecto, that's 100 of something. 10 to the 3, kilo, 1,000 of something. Or we can go down the other direction and get smaller. We can say 1/10 of something, or 10 to the -1. We can say centa, 1/100th of something, or 1 to the -2. Or a milla, 1/1000th, 10 to the -3. And again, if you want to convert between units, you're just moving a decimal place. The next thing you need to know is, what do I mean by a base unit? Okay, base unit, that's 1 of something. We have different base units for different measurements. For distance, we use meters. For volume, liters. For mass, grams. And for time, seconds. Now we're going to practice some conversions. So let's start with meters. And we're going to put our base unit as 1 meter. We use just a lowercase m. And I want to look at this first conversion right up here. 150 centimeters is how many meters? So we'll be starting right here with centimeters. And we're moving our decimal point 1, 2 spaces to the left. And that looks like this. 155. We've got a decimal point. And you're just going to move it from here to the left, 1 space, 2 spaces. And that gives you 1.5 meters. Now in your notes, I want you to practice the rest of these conversions right here. I just did the first one for you, and I want you to practice the next 6 on your own. Write them down in your notes so that you can come back and look at them and refresh your memory if you need to at another time. a picture that you have glued into your journal. You'll see that we can go all the way up to a tera, so a terameter, teraliter, teragram, terasecond, and we can go all the way down to a pico. Again, remember the exponents didn't really work very well here, so that should say 10 to the 12th power, this one 10 to the 9th, and so on. Lucky for you, it's correct in your picture. So this is a really good reference point for you to come back and say, now how do I multiply that? How do I convert that? How many times do I have to go to get from one to the next? The next thing you have to do is some more practice problems. I want you to copy these problems into your notes and solve them. So the first section is converting units. You're going centimeters to meters, millimeters to meters, liters to milliliters, and so on like that. Go ahead and copy everything down, all of the letters, and write your answers in. The second part, you're comparing size. So which is one bigger, smaller, or are they equal to each other? And then the last part is figuring out whether Mr. O'Connell is going to hit his head on his new lamp. So you'll have to convert all of those measurements into the same unit. It does not matter which unit you choose to use. It's totally up to you, but you'll have to convert them all into the same thing to figure out if Mr. O'Connell is going to hit his head. And the last part is, again, just comparing size. So you're looking in the first section, rank them from heaviest to the lightest. So which has the heaviest mass in grams to the lightest. And the second part is ranking from the longest to the shortest. So the longest distance in meters to the shortest distance.